Today we will be discussing prime factorization. First of all, a prime number is a whole number greater than 1 whose only whole number factors are 1 and itself. 3 is an example of a prime number because the factors are only 1 and 3. And 13 is considered a prime number because the whole number factors for 13 are only 1 and 13. The opposite of a prime number is a composite number, and a composite number is a whole number greater than 1 that has whole number factors other than 1 and itself. So I have two examples of composite numbers. 4 is composite. The factors are 1, 2, and 4. So it has another factor besides 1 and itself. And the same for 15. It has two other factors that are different from 1 and itself. So 4 and 15 are considered composite numbers. Just so you know, the number 1 is neither prime nor composite, and if you look at these definitions, a prime number and a composite number both have to be whole number greater than 1. Remember. To factor a whole number as a product of prime numbers is called prime factorization. So this is one method we can use to do prime factorization. It's called a factor tree. A factor tree is a diagram used to write the prime factorization of a number. So here I want to know what the prime factors of 54 are. So I can start my factor tree by writing 54 up top and figuring out that there's two factors that multiply together, 2 and 27, to equal 54. Since 2 is prime, we can move it down, and since 27 is composite, we have to break it up a little more. 27 is the same as 3 times 9. 3 is now prime. Keep our 2 because it's also still prime. And our 9 is composite, so we have to break that down into 3 by 3. So now 2, 3, 3, and 3, all those numbers are prime numbers, so that's our bottom level of our tree, our factor tree. I also wanted to show you another example for 54, starting with different numbers, but showing that you end with the same. 1, 2, and 3 threes. And 1, 2 is written as base 2, and 3 threes is written as 3 cubed, where this exponent is used if the prime factor appears more than once. So since it appeared multiple times, we can give it an exponent. And like I said, 3 times 18 is 54. 3 is prime, 18 is not, so 18 can be broken into 3 times 6. 6 is now composite, so we break that down, and 6 is 3 times 2. So now that we have brought down our 3 here, our 3 here, and now we have a 3 and a 2, so we see that this is in fact the same as this. So we have example. A class of 36 students is on a field trip at the aquarium. The teacher wants to break the class into groups of the same size. Find all possible group sizes by writing all the factors of 36. So our next method, we just learned about the factor tree. Now we're going to do a list. You start with 1, and 1 of course is multiplied by itself, so 1 times 36. Now we check the next digit, 2, or the next number, 2. 2 times 18 is 36. Now after 2 we check 3. 3 times 12 is 36. Now let's check 4. 4 times 9 is 36. We check 5. 5 does not go into 36. So we check the next number, which is 6. And 6 times 6 is 36. Now if you go to write the next number that comes up, it's going to be 9 times 4. And you see that we've already written 9 times 4 up here, just in a different way. So this is one method to use. I personally love using the rainbow method. The rainbow method organizes it pretty much the same way, but it lets you connect the factors that are multiplied together. So how you want to start writing this is 36 equals 1 and 36. And so from there, you do 2, and what is 2 multiplied by? 2 multiplied by 18 equals 36. And you move in, and since 6 is multiplied by itself, that's your center point. And so all of these should connect. Now if you were to have a number in here and you tried to connect it and there was no number over there, then maybe you did something wrong. So it's a good way to go back and check, make sure everyone's got a pair, except for maybe the middle number, and then you know your factors this way. So we've figured out the answer to this problem. The possible group sizes are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And that's all for prime factorization.